All right, folks. So you're seeing my little E blipping because I don't yet have my camera hooked up, but I will soon. As you may or may not know, apparently I have COVID, or so the little test thingy says. So I'm going to be out for a day or two. I talked to Mr. Graham, and he is going to check with our tech people, and we're going to see about getting a computer hooked up in the front of the room that can connect directly to the meet with the camera facing all of you, so that on like I don't know, Thursday, Friday, whatever days I'm going to continue to be out, I will actually still be teaching your class and we'll be able to do our entire workload, which will be spectacular. Now, today is going to be a little bit different. I'm going to get you started on a couple of different things and let's just get going with that. All right. So, first things first. If you take a look in Schoology, you will see COVID sick days, the green folder. Inside the green folder, you will find the daily classes, the links directly to videos like this. In addition, you're going to find the other work. I'm still building it. There will be more. Don't you worry. I know all of you were super upset and concerned that maybe you would not be able to still have class with me, but I promise you, I will not let that happen. So let's move on. All right. Last time we were talking about homologous structures. Remember, homo, same structures. The humerus in a human is the same as it is in most other mammals. Radius and ulna makes up our lower forearm, just like it does in just about all the other mammals. Carpals, metacarpals, phalanges, wrist, hand, and fingers. Once again, those bones are conserved. They are reused. Here is a question for you. Why are cars four wheels with a steering wheel and a couple of pedals to control it? And think about that. Do you think that we haven't had other options? I mean, for God's sakes, at this point, the computers are basically doing everything for us, but yet we still rely on this weird little circle that we turn left and right in order to control where our car goes. All right, I want you guys to understand the reason we still have the basic design of a car: two wheels in front, two wheels in back, people sitting somewhere in between them, engine in the front, storage in the back, is generally because that design worked. The Model T that Ford made was a good enough car. It got people around. It did what it was supposed to. So we haven't reinvented it. Neither does evolution. It just takes what already works and it just tweaks it. It just modifies it a little bit for what it's going to be doing, just like we've done with cars. Remember, whenever you see this term, homo, that Latin prefix means same. All right, we talked about how the embryos are very homologous. They look very similar at the first stage. By the second stage, we're starting to see some differences. By maturity, we can obviously see a great deal more. And whoever drew this doesn't know what a human being looks like because that's just disturbing. Look at the noodle arm. Yeah. All right. Analogous structures. Also in the lab yesterday. So hopefully, if you don't remember, here's the definition for the lab. Same function, unrelated. Like the flippers of these animals, the wings of these do the same job, function, but there's no relationship evolutionarily to one another. And finally, vestigials. Vestigial structures are great, and I kind of left this one off, so you guys would have to look it up. But vestigial structures are these really interesting leftovers, right? If we cut open a whale, and sadly, people do this, um, we can still find pelvic bones in them. Leftovers from back when they walked on land, back when they had four legs. It hasn't completely faded away yet. We also see things like the tailbone in people. If you have fallen hard enough to break your tailbone, you know how painful that is. Why do we have it? Well, it's because at one point we actually had a freaking tail, but that's gone away. And so as the part reduces, it's getting closer and closer to completely disappearing, but we've still got some of it. Or all sorts of other things. Humans are a gigantic sack of vestigial organs. We have so many things that we don't use anymore. Wisdom teeth were great when your teeth rotted out of your head by age 20, but now we have oral hygiene and we really don't need them. Matter of fact, we don't need them to the point where most of you will have them surgically removed when they start to come in because they're going to crowd your teeth. They were originally replacements. To have new teeth come in after all the rest of your teeth have rotted out, that's fantastic. Goosebumps that lift the hair on your arms and neck upright, just like a cat. Cats use it in order to look bigger than they are to try to intimidate and avoid a fight. We did too. We still have those tiny little muscles connected to our tiny little hairs, but we no longer have enough hair to do that, unless you're me. Our appendix is this little dangly bit right here off the large intestines. What does it do? Right now, what is the only thing the appendix does for us? It gets infected and it tries to kill you. That's it. That's all it does. It has no other functional use in your body. And for most of you, we're not going to remove it unless it becomes a problem. But if you start feeling that abdominal pain and it gets worse and worse, you better bet that they're going to go in after the appendix because it's just a leftover piece. It used to have a function, it doesn't really anymore. So that's really what all of this is about, right? All of these different things, the homologous structures, our fossil record, where we see similarities and differences across what lives where, all of these things are the pieces that we use to prove the theory of evolution. And it's good evidence. Nothing has disproven it yet. Make sure you know these five. Now, Mendel, remember, Gregor Mendel was the father of genetics. He was the one who was coming up with how how inheritance works. Well, he did figure out his part. He did send it to Darwin, and if Darwin had read it, all of the mysteries would have been fixed. But he didn't. Once again, remember, Darwin was not some sort of superior human. He was just a guy. He was just the right person at the right place at the right time. So let's go on to modern evolution then. This is past Darwin. This is with Mendel and genetics. We can finally understand everything. So the white text here is an important idea. I'm not having you guys write this down because it's still natural selection. It's just both of these things together. So take a moment. Through the process of natural selection, the most fit pass on the alleles for the traits that made them successful. That makes sense. We've done genetics. This will change the population over time as the new trait becomes more and more common because it gives them an advantage and those that have it survive. At some point, so many of these enhanced traits will exist that the species can no longer be considered the same thing, right? This is modern evolution. And it all comes down to adaptation. Excuse me. It all comes down to understanding how organisms adapt to fit in with their environment. The gecko here is a fantastic example of this. If you just see a bunch of brown dead leaves, that's what it wants you to see. So that's what we're going to look at today. And the next thing that I'm going to bring you guys to look at, all right, here is the HHMI rock pocket mouse video. This is fantastic. I want to make sure everybody watches it. Now, whoever is in charge, whoever is subbing, they can get this rolling up front for everybody. It literally, you look up this word on YouTube, boom, it'll be right there. Or people can watch it on their own, but make sure you watch it. I will be testing you on this video. Good. Now, the second one will be this case study. This case study has some particular rules, though. Um, it's very interesting looking at fiddler crabs and the gigantic claw they have. It's literally bigger than their body. But what I want you guys to understand is you're going to do part one, right? Answer these two questions. You're going to do part two, where you brainstorm and try to come up with ideas. You are going to skip part three. All of this, these graphs, and these questions here. All of this. But then I want you to finish part four, which once again does not have too much. Literally just this. So 1, 2, and 4. 1, 2, and 4. 1, 2, and 4. 1, 2, and 4. Fantastic. Now, because I'm not there, I can't print this out. I can't provide it on the front desk to be handed out. This one is going to be online. The turn in will be in Schoology. I apologize for it. The substitute might be able to print a copy or two, and then people can run down to the library to work on it. I will leave that up to you. Um, for Bell 2-3, you guys should be able to get this done today. For Bell 7, I do not expect you to get this done in one bell. So this will bleed over into tomorrow, and so on and so forth. All right. Well, that will settle us up for right now. Ladies and gentlemen, have a great day. I will be here. I am not disabled. The rules just say I can't be there. See you soon.